So this is where we are introducing aggregate awareness. So the main gist of it is that we are rewriting SQL to use the smallest table available. The benefit is that we are getting faster and cheaper queries. We're consolidating redundant explores. In this example here that I got from the Looker documentation, we have three optional tables, each of different size, both in columns and in rows. And Looker is accelerating that query and pushing it to the most optimized table without cubes or silos, which are BI engine specific terms. But next, how does it work? How does it work in LookML specifically? So we define these tables, aggregate tables, in the LookML, and we materialize them as persistent derived tables or PDTs. And as soon as that table is defined, Looker will use those tables whenever mathematically possible or reasonable. The example on the left-hand side is showing a template of an aggregate table where we have predefined dimensions, measures, and filters. So if there is any combination of those being used or required as part of a query, then Looker will know to point to this one. And I've got this example on the right hand side here, which is showing actually a really interesting element of this querying of an aggregate table. This example of the flights example, which has this dimensions and measures. The interesting thing here that I wanted to point out is when you run a query, if you go to the SQL, you can see it will comment out that it's using a an aggregate table which is coming from a scratch schema. So it's saying this is using this aggregate table, which is in a specific scratch schema, and that's what it's called. So users should be fully capable of recognizing when the aggregate query is coming into place. The next thing that's really interesting is time intelligence. Looker can, as I said earlier, derive time from other versions of time, if that makes sense. So day can be derived from hour, week and month can be derived from day, and year can be derived from week and month. You might be able to even derive year from day, but it won't do it unless it's optimal and unless it actually saves on resource. The next thing is that we can really guarantee to have the latest data. We can have an aggregate table, let's say for the past 7 days, and rather than refreshing that every single day for the next 7 days, we can for the next 6 days we can just union the latest data on top of that. So it will only refresh every 7 days, but it still has freshness because we are unioning the latest data. So it's not exclusively limited to the filter that we add to the aggregate table. And the third thing, which is possibly the most interesting, depends who you speak to, I suppose, but the aggregate table can have time overlaps. So let's say we have an example where we filtered the aggregate table to be for the last 14 days, last 2 weeks, but the query is actually for the last month, so the last 30 days. It doesn't actually completely ignore the aggregate table. It will take half of the information from the aggregate table and then query the other half. So you are still saving on resource. So there really isn't a downside here, at least for in this context.